Okay, today we're going to talk about section 7.8, which is multiplying polynomials. So basically what we're going to do is we're going to learn how to multiply polynomials using different methods, including what we call the FOIL method, which we'll talk about eventually down the road. Okay, so first of all what we're going to do is we're going to talk about what I would consider what we call first stage multiplication, which really is using monomials and just kind of multiplying things together using combination of associative and commutative properties to be able to simplify this. And so the first thing that we're going to really want to do here is we're going to want to combine, or not necessarily combine, but associate like bases. So we want to get things that have the same base so that we can use our properties of exponents and things like that. So what we're going to do is we're going to say 3 and 3. We have m and an m, and we have an n and an n. If we use our commutative property, we can do the following. So we can say 3 times 9 times m to the second power times n to the second power times n. Now we can do this because, remember, this is all multiplication. So since this is all multiplication, using those two properties, we can do such a thing. And then so finally, once we combine these, then we get 27 times m to the third times n to the third, because remember, when we're multiplying bases, then we're just adding our exponents. And then what we can do is, to make this look a little bit nicer, we can kind of condense this a little bit to say 27 m to the third n to the second. So we're just using our two properties in order to do all this. Okay, so if we look at our next example here, do the same thing. We have 1/4 and negative 12. We have s squared, s, and s, and then t squared, t, and another t squared. So if we get these kind of close to each other, then we get the following. Our numbers out in the front, so 1/4 times negative 12 times s to the second power times s times one more s times t squared times t squared. And if we combine those and use our associative property, we get this to come out to 1/4 times negative 12 is going to give me negative 3 times s to the second times s ends up giving me s to the fourth times t to the fifth, because t squared plus t to the first plus, well, not plus, but times t to the first times another t to the second. Add all those up, we get 5. And then so what we can do is we can condense this again. So we get 3 times s to the fourth times t to the fifth. So we just want to make sure what we're doing is we're combining everything that has a like base. So this moves us on to what I would consider second stage multiplication, which we're taking that monomial and then now we're adding in something that isn't all multiplication. So we can't just use our multiplication properties. We need to use a combination, and whenever we see something out on front and we have addition or subtraction on the inside, we need to use our distributive property. So we're going to distribute, but we're going to keep in mind our properties of exponents if we need to. So the first example, we take this 4 out in front and multiply it by everything on the inside. And before I do that, I'm going to add the opposite here. And so when I end up distributing, I get 12x to the second power plus 16x plus negative 24. So really all I'm doing here is I'm just multiplying the numbers. Okay, nothing's changing with my variables. In our second example, we potentially have things that could change in our variables. So I'll show you what this is going to do. So if we look at this example, again, we still need to distribute, but we're distributing this whole piece. So this is all multiplied out in front, so we can distribute it all at one time. And then we can do this here. Again, I'm going to add the opposite just to avoid some confusion. Now what we're ending up with is we're ending up with 6 times p times q times 2p plus 6pq times negative q. And so we can go back to what we did on the first page and say, okay, well, I'm going to do this again. So I get 6 and 2 gives me 12. P and P gives me P p to the second power, because remember, this is multiplication, and then times a q, plus, again, I have a q and a q. I have a negative 1. Remember, there's a 1 out in front. Negative 1 and a 6. So I get negative 6 times p times q to the second power. Now I need to look at these. Are these like terms? If they're like terms, then I can go ahead and add them. But if I look at this closer, I have p to the second q, p and q to the second. These are not the same, because if they were the same, the exponents on each variable would have to be exactly the same. So here, what I'm doing is I'm distributing and then just using my properties of exponents to finish this out, just like I did with the first stage multiplication. Now, moving on to what we would consider third stage multiplication, deals when we're multiplying two polynomials together. Now, in this case, with the two polynomials, things are a little bit different. This isn't as simple as just plain old regular distribution, because with the distribution we had something multiplied. Now the thing that's being multiplied ends up being an entire polynomial, which kind of changes things a little bit. But the way that I can do that is I can multiply each piece inside the first polynomial, this one here, to the next one. So what I would do here is I would take this x and multiply it by this entire thing. And then I would take this 3 and multiply it by this entire thing, and then add those two together because of this addition. So what this would end up being is I would have x times x plus 2 plus 3 times x plus 2. So taking each one of those terms and multiplying it by the whole polynomial. And then I can go back and do this just the way that I did before. Distribute an x, distribute an x, distribute a 3, distribute a 3, and end up getting x to the second power plus 2x plus 3x plus 6 once I distribute. And then now I can look for like terms here and here and end up going x to the second power plus 5x plus 6. So what I'm doing here is, instead of just multiplying one piece, it's both pieces to the entire second polynomial. And the trick here is that when I see this addition, that's what complicates things, and that's why I have to rely on different types of multiplication strategies in order to do that. Okay, so the next type of way that I can multiply these polynomials is what we call the FOIL method. And the FOIL method is as follows. It is first, outside, inside, last. And now what we need to do first is we need to look at this polynomial here and realize, okay, well, we can't just use our typical exponent and just say, well, can't I just distribute these two things here? Well, no, that's not going to work, and that's not what we want to do, because it'll give us the wrong answer. The way we need to treat this is treat this as what is actually happening. Think about this. What this is really saying, and this is saying x plus 3 times x plus 3. Now I want to use my FOIL method, which the FOIL method tells me that I first need to do the first set of terms. First set of terms is basically the first two. So we have x times x. And this whole time we're using multiplication. So my first set of terms gives me x squared. My next set of terms is my outside terms, which are the terms that are on the outside of the entire bracket. So we have the outside and we have the outside. So we have x times 3, or we can say 3 times x, because remember, multiplication can go in any order. My next set is my inside terms. So my inside terms are these two. So I have x times 3, or 3 times x, so 3 times x. And then finally I have my last set, which are the last terms. So I have 3 times 3, which is 9. Now, the thing about these all is that these are all being added together. So I have x to the second power plus 3x plus 3x plus 9, which really we can combine these two here to give us x to the second power plus 6x plus 9. And then there's my answer. So using the FOIL method, we do the first, the outside, the inside, and then the last. This is just another fancy way of just multiplying each one of these terms by everything else that's included with it. Okay, so we're going to do a couple more examples using our FOIL method. So if I do the first outside, inside, last, so FOIL, first, outside, inside, last. So my first terms, a and a, gives me a squared plus the outsides, so a and I'm going to say plus negative 4, so plus negative 4a for my outside. My inside terms are 3 and a, so we have plus 3a. And then my last terms, so 3 and negative 4, gives me plus negative 12. Combining my like terms, I get a to the second power plus negative 4, no, not negative 4, I'm sorry, negative 1a plus negative 12. And that's it. And if I do that same method here, now the only thing that I have to worry about here is have to worry about my exponents and using my properties of exponents in order to do this. So the first thing I'm going to do on this next problem is add the opposite. So I do my first, outside, inside, last. So my first terms, 2a times a, ends up giving me 2a to the second power. I do my outside, so 2a and 4b to the second power, which is going to give me plus 8ab squared, because notice that I can't multiply a and combine it with b squared because they are not the same thing. My next set, I have my inside, so a times negative b squared is going to end up giving me plus negative 1 b to the second a. And then finally, I use my last terms, which give me negative b squared and 4b to the second power, which is going to give me plus negative 4b to the fourth power, because when I add those together, I get b squared times b squared, which gives me b to the fourth power. Negative 1 times 4 gives me the negative 4. And so if I combine like terms, I'll notice that this is all by itself. This one, the negative 4b to the fourth, is all by itself. But the question is, are the middle terms, so this and this, are these like terms? Remember, I told you that it doesn't matter which order that we do this in, that remember this is negative 1ab to the second. Those mean the same thing. So we can see that these two are like terms. So if we write these, then we'll end up writing this as following. So 2a to the second power plus 7ab to the second power plus negative 4b to the fourth. Now remember, our standard form of polynomials tells us that the highest degree goes first. So this has degree of, so the first term has degree of 2, this has a degree of 3, so this is the degrees, and this has a degree of 4. So we have to write that in that order. So negative 4b to the fourth plus 2, or no, not 2, because our next one is the degree 3, so 7ab to the second plus 2a to the second power. And then that's our final answer. So now when we're getting to something where we have multiple polynomials or large polynomials, we can do one thing, and we can kind of use the old method of what we did by just simply saying, well, first of all, we can't use our FOIL because we don't have middle terms and everything like that, because now this polynomial here, this has 3 terms, and so the whole FOIL method kind of gets thrown out the window. So whenever we come into a situation like this, what we can do is what we did before and say, well, I'm going to multiply this 5x by everything over here, and then what I'm going to do is I'm going to multiply this 3 by every single term. and do it that way instead. And so before I do that, I'm going to make sure that I add my opposite. So add the opposite to get negative 6. And so if I do this, I have 5x times 2x squared plus 10x plus negative 6, and I have 3 times 2x squared plus 10x plus negative 6. That works the same way. And so as I do this, you can see that either way I'm going to end up distributing. So distribute, 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 and distribute. And so what I end up with here is I have 5x times 2x gives me 10x to the third power plus 50x squared plus negative 30x plus 6x squared plus 30x plus negative 18. So now I have to look for my like terms, and I can see I have one here, I have here and here, I have x and x, and then I have just a regular plain old negative 18. So as I combine these two things, I get 10x to the third power. 50 plus 6 gives me plus 56x squared. I have negative 30 and I have positive 30, so that just gives me a 0, which I don't have to include that. And then I just have my plus negative 18. So there's different ways that we can do these large polynomials, but the first way that we can do it is just with this, in a way, we can call it double distribution, so that we're distributing everything inside the first polynomial individually to the second polynomial. Another method of multiplying these large polynomials is what we call a lattice style. And so what we can do is we can kind of set up a table and do it this way. So if I set this up as a table, I can set it up either way. It doesn't really make a difference. And so I have this kind of lattice style. And so I could say my first polynomial has the following terms. I'm going to add the opposite so you can see this a little easier. And so my following terms, I have an x and I have a negative 5. And I'm going to put those in different colors just so it's easier to see. So I have this one here. This polynomial is x and negative 5. The second polynomial, which I have here, gives me an x squared, a 4x, and a negative 6. And so what I can do is I can do this as like a multiplication table. And so I can say, well, x times x to the second power is just x to the third power. X times 4x is 4x to the second power. And x times negative 6 is negative 6x. Here we have negative 5 times x squared, which is simply negative 5x squared. I have negative 20x because negative 5 times 4x. And then I have a positive 30 because negative 5 times negative 6 gives me 30. Now this answer, everything that's in green here, is going to be my new polynomial. And so what I can do is I can immediately look for like terms. I have a like term here and here, here and here. And so what I have left over is I have x to the third plus negative 5 plus 4 gives me negative 1x squared. And I have negative 20 plus negative 6 gives me plus a negative 26x plus 30. So I can use this lattice style too as well to basically set up a times table and just to pick out each term. So it's a little bit easier to organize, but you can see I'll still get to the same answer. Okay, and like always, what you have the option of doing is you have the option, which is strongly suggested, that you go ahead and go to section 7-8 in your book and do some of the guided practice problems. But again, make sure that you do the odds, because the odd problems, what they're going to do is they're going to give you a walkthrough of how to do that. And then, like I said before, is we're going to do more difficult problems once we get to class. But that's going to end it up for today.